We are now going to revisit some of solving trig equations that you did last year in grade 11, now in grade 12. The difference is often we take away the calculator and it has to be non-calculator, in which case you have to use your unit circle, and your answers are in radians. So just as a review, this question could have appeared on last year's final exam. On last year's final exam, it would have looked like this. Solve for sine of theta, negative root 3 over 2, but instead of radians, you would have degrees. And instead of not having your calculator, you would have had your calculator. So the first thing you would have noticed from your CAST rule is that sine is negative, so your answers could be in quadrant 3 or in quadrant 4. Either way, there's your reference angle. If you make a triangle back to the nearest x-axis, you could label opposite over hypotenuse would be root 3 over 2. You would then go to your calculator and you would calculate your reference angle by doing sine inverse of positive root 3 over 2. Again, your reference angle is based on that little triangle. Triangles all have lengths that are, all the sides are positive values. So whenever we're figuring out our reference angle, we're always using positive values. From that, you would have typed this into your calculator and you would have found your reference angle is 60 degrees. So you would have said, well, as a result, I know my answer theta in standard position would be 180 plus 60, which would be 240 degrees. And for this one in quadrant 4, 360 minus 60, 300 degrees. And that's how you would have done it in grade 11. Now we're in grade 12. We have this same question, but the difference is it's in radians, and this question would be non-calculator. And the reason it's non-calculator is because this is one of your values on your unit circle. Remember on your unit circle that sine is your y-coordinate. Is your y-coordinate ever root 3 over 2? Think in quadrant 1. If you're thinking in quadrant 1, when is your y-coordinate root 3 over 2? Because that will be your reference angle. Pi over 3. And then, because sine is negative, according to your CAST rule, it's going to be in quadrants 3 and 4. What's your pi over 3 family member in quadrant 3? What's your pi over 3 family member in quadrant 4? And that's all the work you're going to have to show. Basically just the answer, because it's directly from your unit circle, directly from your pi plate. So again, we're going to do these ones in radians from 0 to 2 pi. These would all be non-calculator. So starting with this one, cos of theta is equal to negative 1. Cos is your x-coordinate. Is your x-coordinate ever negative 1 on your unit circle? When? 180 degrees, but now we're dealing in radians. We just write pi. And that's all we need to show. Solved. A lot quicker than having a calculator. Tan of theta is equal to negative 1. Is tan ever 1? What family? That's your pi over 4 family. And if tan is negative, what quadrants would we look in? Tan is negative in quadrants 2 and 4. So the pi over 4 in quadrant 2 is 3 pi over 4. The pi over 4 in quadrant 4, 7 pi over 4. So you see, we can get a reference angle really quick if we recognize one of the values. If you had secant theta, again, Secant theta is not on our pi plate, but we could change this to cos theta. Notice the angle doesn't change, but the answer becomes the reciprocal. Is 1/2 ever your x-coordinate on your unit circle? What family? Pi over 3 family. When is cos positive? Quadrant 1, so that'll still be pi over 3, and quadrant 4. Five pi over 3. If you have an equation like this one, 2 sine theta plus 1 equals 0. In grade 11, you would have got sine by itself. Well, I can do that by subtracting 1 on both sides and then dividing by 2. And then sine is your y-coordinate. Is your y-coordinate ever 1/2 on your unit circle? What family? Pi over 6. And if sine is negative, you would be looking in quadrants 3 and 4. So the pi over 6 in quadrant 3 and the pi over 6 in quadrant 4. Also in grade 11, you solved quadratic equations. When you solved quadratic equations with something like an x squared, you made one side equal to 0 and you factored it. That was sort of the main strategy that you had. The same thing happens if you have quadratic trig equations. Usually we like to have one side equal to 0 and factor it. Now, when factoring this, you might notice there's a common factor of cos. And so I can factor that common factor out, leaving me with cos theta minus 1 equals 0. Now, do you know why we factor to solve these? Or do you just know that that's what we need to do? Like from grade 11, you learned to set one side equal to 0 and factor to solve. But why do we do that? What's the advantage of factoring over what we had to begin with, which was just subtracting? Probably my guess is that from last year you just did it enough times that you remembered how to do it. But if I asked you, today's quiz was, why do we factor? You might not have an answer for me. You'd probably just say, well, that's just what we do. I learned that that's what we do. Well, I'm going to give you a reason why we factor. Okay? Why do we change from here we're subtracting two things to here we're multiplying two things? Well, if I have a number in my head, okay? I'm not going to tell you. Your job is to try and guess the number that I have in my head. And then I'm going to subtract another number in my head, and the answer is 0. Try to guess the number that I have in my head. It's not 3. Try again. 10. It's not 10. It's not 6. Not 7. Could this take a long time? Right? You could be guessing for a very long time. I had 5.75. Kind of mean that I had a decimal, right? But 5.75 minus 5.75 is equal to 0. And it would be very hard for you to guess that. Okay? When we factor, we change something. Here I'm subtracting two things. When I factor, I change it to multiplying two things. So now I'm going to put two numbers in my head. I'm going to multiply them together. The answer is 0. You have to tell me one of the numbers. 0. Right? If you're multiplying two numbers and the answer is 0, one of the numbers has to be 0. There's no other way that that's possible. That is very powerful. The other one was 3.6. I don't think you would have got that one. But one of them was 0. And when I change this By factoring, I change this to a multiplication. And now it's something times something equals 0. So that means, if I split it right here, one of those two has to be 0. That's the only possibility. Well, if the first one is 0, that's easy. Cos theta would be 0. If the second one is 0, cos theta minus 1 would be 0, or if I rearrange that by adding 1 to both sides, that would mean cos theta equals 1. So looking at the first one, when does that happen? Is your x-coordinate ever 0 on your unit circle? Yes. What angles? It's your axis family at pi over 2 and at 3 pi over 2. Is your x-coordinate ever 1 on your unit circle? Yes. When? At 0 and at 2 pi. And notice here, our domain says go from 0 to 2 pi, and with those equal signs means that we need to include 0 and include 2 pi. You'll see sometimes in your textbook, they'll have it written like this. And then your only answer would be 0 because 2 pi is not in the domain. So one of the things that we'll do as a practice is when we solve our equations, we're always going to go back and check our domain so that we know that we're solving over the right interval. But that's the power of factoring. You change things that are adding and subtracting to equal 0, which you can guess and check for a nice long time, to two things that are multiplying to equal 0. And when two things are multiplying to equal 0, one of them has to be 0. So you run through both the possibilities. What if the first one's equal to 0? Well, then these are my answers. What if the second one is equal to 0? Well, then these are my answers. And all four of those answers work. Terribly powerful thing to factor when something is equal to 0. And that also explains why it has to be equal to 0. Because if I factor and it's equal to any other number, it doesn't work out well. I have two numbers in my head that are multiplied to give me 2. You're probably thinking 1 and 2, but that's not the case. I had 2 7s and 7. Well, that also multiplies to be 2, but there's infinite amount of answers. It's only when it's equal to 0 that one of them has to be 0. And that's what makes factoring so powerful.